Okay, welcome back, class. Glad to see everyone's back. Hopefully, everyone's getting into the swing of things. Hopefully, things are starting to calm down a little bit. We're back into our classwork, our coursework, and some type of semblance of normalcy is starting to return. Lesson 3 in 70-741 takes our concept of installing DNS and using DNS and builds on it with how we do all the different things in DNS. Creating primary zones, creating and configuring secondary zones. The fact that we can integrate our Active Directory with the primary zones, with DHCP, with our Active Directory, with WINS, so that when a computer gets added to our Active Directory, DNS updates. A computer requests a IP address from DHCP, it gets updated in DNS. All these things happen automatically. Stub zones, all the different types of DNS records we're going to be looking at. A records, quad A records. We've talked about those before. But what is a pointer? Pointer's what resides in the reverse lookup zone. The SOA, the start of authority, the NS, the name server, service records, CNAMEs, which is also called an alias, and MX, which is mail exchanger records, how we find mail servers, and many other topics. But let's roll into it. So, as we previously talked about, the steps in deploying DNS is install DNS on one or more servers, configure that server, create forward and reverse lookup zones, add the necessary resource records to those forward and reverse lookup zones, and then finally tell our clients to use those DNS servers, because if we don't give that DNS server address out to our clients, what's the purpose, right? So understand that a primary zone provides an authoritative read-write copy of the zone. A secondary zone provides an authoritative read-only copy of the primary zone. So make sure you understand that. Primary is a read-write, a secondary zone is a read-only copy of the primary. A server can host all primary zones, all secondary zones, or a mix of primary and secondary zones. When we list those, we may list them as referring to them as primary name servers and secondary name servers. When we look at our DNS server console, DNS server manager console, when we drill into our server name, we'll see a forward lookup zone and a reverse lookup zone. Forward lookup zones contain most all the resource records for a domain. The reverse lookup zone is what gives us the ability to resolve an IP address to a host name. You know, we've done this many times in the class. You know, if you ping an IP address to see whether it responds, because we're trying to troubleshoot connectivity or verify something, and it gets a response, we say, well, wait a minute, we need to know if DNS is working. Well, if you do that same ping with a -A and then the IP address, it'll attempt to resolve the host name from that IP address. If it works, you know DNS is successfully responding. So now, this is one of the step-by-steps that I copied over. We're just going to go ahead and ignore that, and we're going to move on. Okay. So understand that today DNS can be stored in and replicated with our Active Directory. Remember that when we create a domain controller that's part of our Active Directory, every object, and remember what an object is, it's a computer, it's a user, it's all those different components that go in our Active Directory. When a new computer gets created, that account is replicated across all domain controllers. Well, the same thing occurs with our DNS. Our DNS can be stored in and replicated with Active Directory as an Active Directory integrated zone. By doing this, the DNS follows what we call a multi-master model, where each server enables all DNS servers to have an authoritative read-write copy of the DNS zone, just the same way as our Active Directory works. When a change is made on one DNS server, it's replicated to all the other DNS servers, so your DNS stays uniform. We can have what's called zone delegation. A DNS subdomain, it's a child domain that's part of a parent domain. Has the same domain suffix like myserver.com or mynetwork.com. Subdomains allow you to assign unique names to be used by a particular department like research or sales, subsidiary function, or a service. This can be used to help increase performance on the DNS zones. A stub zone is a copy of a zone that only contains the necessary resource records, which is the SOA and the NS, and of course those A records, in the master zone. And it acts as a pointer to the authoritative name server, so it simply is a way to get to it. The stub zone allows a server to forward queries to the name server that is authoritative for the master zone without going up all the way to the root name servers and working its way back down, because remember how DNS works. If it doesn't know about something, it tries to contact one server and it goes to the root, and then the root goes to the secondary, and so on and so forth. This allows you to bypass all that, and it helps to increase performance. However, it does not provide any redundancy or load sharing. Conditional forwarding is a way that we can expand on the idea of forwarding. So let's say that we have two partner organizations that communicate with each other, and they do it through a VPN tunnel. Well, domain1.com and domain2.com are two different separate domains in two different DNS environments. Domain1.com doesn't know anything about the resource records in domain 2. By using conditional forwarding, you can allow you to forward requests to the partner's DNS when you're trying to access one of their resource, and so that way you can get access to their information, and because otherwise you'd have no way to resolve their names. Excuse me. So zone transfers are what occur when we do either a complete or a partial transfer of DNS data on a DNS server to another DNS server. So understand that is how DNS zone transfers are used for, and the way that they occur. Excuse me, let me take a sip of coffee here. Okay, so what happens is the initial transfer occurs when a secondary zone is created. The zone refresh interval expires, the DNS server service is started at the secondary service, and that master server notifies the secondary server that changes have been made to a zone. There are three different types of zone transfers. What we call an AXFR, or a full zone transfer, which copies the entire zone. This is used when you first add a new DNS secondary server for an existing zone. You have the IXFR, which is the incremental zone transfer, and it only retrieves those resource records that have changed within a zone. And then, of course, you also have a polling method, the primary server for serial numbers, the DNS notify method. This allows the primary DNS server to use a push mechanism to notify secondary servers that it's been updated and that the RRs, or resource records, need to be transferred. We can also use our command prompt to do DNS manipulation and configuration. Using the DNS cmd.exe command allows you as an authorized administrator to display, change properties of the DNS servers, the zones, the resource records. Understand that because you can execute this in a command prompt, you can use it in script batch files. So this can be used to help automate the management updating of DNS server configurations. Prior to Server 2008, DNS CMD did not exist. It was introduced with Server 2008. So understand that using this command, you can create, delete, view zones and records, reset servers, reset zone properties, perform maintenance, clear the DNS cache, start and stop the DNS server, and view statistics. We can also use PowerShell. There's many PowerShell commandlets, as we've seen with many other functions, that we can utilize to manage zones. As long as you've got those DNS management tools installed, you have access to the PowerShell commandlets for DNS. Understand that DNS also supports what we call dynamic updates. Dynamic updates is where resource records for the clients are automatically created and updated at the host primary DNS server. For example, a client's DHCP IP address lease expires, or it expires, they log back in, they get a new IP address that gets dynamically updated. For Active Directory integrated zones, these records are automatically replicated to all the other DNS servers. So not only do they get dynamically updated, but they automatically then get replicated to the other DNS servers. If we're not integrating with Active Directory, though, understand that standard dynamic updates are insecure. So we only want to ever use secure dynamic updates. Okay, sorry about the delay there. I needed to pause and take a sip of water. So zone scavenging by default occurs every 24 hours after startup. So what that means is it helps to ensure the records are up to date and guards against accidental deletion. This is what it does automatically. However, sometimes records will become what we call stale, and they don't get removed or updated. The DNS database gets outdated, maybe it provides inaccurate information. So to help clean up that stale data, we can configure what's called zone scavenging. So we can set aging in DNS, and that's the process of using timestamps to track the age of dynamically registered resource records. The scavenging is the mechanism to remove those stale resource records. So after a certain period, it would automatically clean that up. DNS record types. There are many different types of DNS records. A resource record is what we're referring to. It specifies information about a particular object. The database is what we use to store all those resource records. Each record has a type, a certain expiration time limit, and some type-specific data. So when we create a user account, think of it this way. Certain properties define the user account, such as first name, last name, and logon name. When you define a printer in Active Directory, you define the name of the printer and its location. Printer doesn't have a first name or last name. Just as you have different types of objects in Active Directory, you also have different types of resource records, and they all have different fields. We already spoke about the SOA, the Startup Authority Record. It specifies authoritative information about a DNS zone. What's the primary name server? What's the email of the domain administrator? The serial number, expiration, reload timers of the zone. This is all contained in that SOA record. The NS record, the name server record, specifies, hey, who is the authoritative name server for the host? So then we also have many other types of records. Here we can take a look at a screenshot, albeit not a very good one. And you can see at the top of the listing there the SOA, the NS name server records, and then we've got a whole slew of A records. And we can, in the middle, you can see a CNAME and alias for a server, and towards the bottom you can see an MX record, a mail exchanger record. So here are our most common types. The A or quad A record, and that maps either an IPv4 or an IPv6 record from a host name to an IP address. Let's skip down to the third one, a pointer record. That maps an IP address to a domain or host name, so it's the opposite of the A record. The second one down, the C name, the canonical name, is also called an alias, and it maps an alias name to a primary or canonical name. So in other words, we could create a record of www.myserver.com, and it could point to server1.myserver.com, and that would be our web server. Fourth item down is MX record, and we use that to point to mail servers, mail exchanger records. The SRV, the service locator record, maps a DNS domain name to a specified list of host computers that offer a specific type of service, such as our Active Directory domain controllers. Now, not listed there are TXT records, which we see many times on public DNS. Most of what we're referring to is on our private or internal DNS servers. So understand that to provide DNS servers, you first need to deploy DNS. You can't do DNS without DNS, right? After we've installed those DNS servers, we need to create the zones that are going to be associated and the required resource records to each zone. The primary zone provides an authoritative read-write copy of the zone. Secondary zones provide an authoritative read-only copy of the primary zone. Today, DNS can be stored in and replicated along with our Active Directory so that it gets replicated. Any changes that happen on one DNS get replicated to all other active integrated DNS zones. Keep in mind that only occurs automatically, and that replication only happens with Active Directory with those Active Directory integrated zones. Using that, we follow what's called a multi-master model. And just as we just said, when a change is made on one of the DNS servers, it's replicated to the other DNS servers. Also, we have zones. We have resource records that specify information about particular objects. Remember, each record has a type, an expiration time limit, some type of specific data. Keep in mind that in an environment where there's several different DNS suffixes, such as contoso.com, datum.com, fabricam.net, which we'll be looking at those in our lab that's associated with this lesson, it's necessary to manually create a global name zone within DNS to allow a single label name to be resolved. Because DNS is such an essential service that can bring a network down when it's not available, you also need to know how to troubleshoot it. There's many different tools that we can use. We can use the ipconfig command to look at settings, the NSLookup command, of course our DNS Manager console. Understand your troubleshooting methodology that's associated with DNS just like you would to troubleshoot a PC. Thank you for your time, and I hope this was helpful.